So here's another problem. Y squared equals negative 6x. So the first thing to realize here is that this is a sideways parabola because take a look at this. I have y squared. And that y squared tells me right away that it opens to the left or to the right. And since I have a negative here, that tells me there that it's going to open to the left, to the negative side of the x-axis. All right, so that means I'm going to be going this way, in that direction. Okay, so anyway, so the first thing to understand is once I realize my direction and that it's a sideways parabola, I think of the general formula for this. And the general formula is going to be y squared equals 4ax, as we seen in the previous video. Okay, so this tells me then, notice here, that I have an x and an x here. So the only difference here is this negative 6 and this 4a. So what that means for us then is I have to get it in that form, 4ax. So then all I'm going to do here is take 4ax, not the x, excuse me, 4a, and that's going to equal negative 6. And then to solve for a, I would just divide by 4. Divide by 4. So a is going to be negative 3/2. All right, so I don't usually put the negative on the 3/2, but I can simply write it just like y squared equals negative 4 3/2x. And then the negative saying, hey, this thing's going to open to the left. Now we actually have enough information to graph this. Almost. We need a couple other points, kind of like we did in the other, like I did in the other video. But here, let's take a crack at this. So again, I'm trying to think of nice numbers that give me nice integer x's and y's. So to do this, I'm just going to use an xy table. So here's my x, here's my y. So I'm just going to draw this down. Now, if I pick a 1 and I plug it in there, there's something I want to show you here. So if I plug in a 1 there, I'm going to get y squared equals negative 6 times 1. So I'm going to get a y squared equals negative 6. And what happens when I square root both sides and I have a negative number? I actually get something imaginary here. So I do have to realize what side of the x-axis I'm on. So if you notice, since I'm on the left side going in that direction, that tells me right away that this, if I'm going to use anything, should be a negative 1. And what I'll find out, if I go through the math here, I'm going to end up with y equals plus or minus the square root of 6, which is a terrible number. And again, like I said, I wanted positive or negative integers. I don't want to deal with these radicals and stuff and try to graph those. Makes it a little more difficult. So what I'm going to do is I'm just going to look for some nice numbers. So I just kind of worked it out here. If you need to pause, that's fine. But notice when I plugged in negative 6, I get a y equals a positive 6 or a negative 6. So this is going to be negative 6 is one of my points, or negative 6 positive 6 is a point. And now I have all the information I need to actually do a nice complete graph. So let's put it all together now. So again, you notice my y's and x's, there's no shifts there. It's just a plain x and a y. So that doesn't change anything. So that tells me my vertex is going to be at the origin. And the next thing to consider is I have the point negative 6, negative 6. So if I go over 6 and down 6, that's going to put me here. And then if I graph the other point, that's going to be up 6, 1, 2, 3, 4, 5, 6. And then over 6, it's going to put me here. Okay. And then we have the directrix. Since my A is 3/2, so from that I'm going to go over 3/2. So it's going to be here. And that's going to be my directrix. I did forget one thing on the last graph, and I'll kind of put it in here. And then my other one, my vertex, so my focus is going to be 3/2 to the right, so that's going to be here. That's going to be my focus. And that point is going to be -3/2, 0. Okay. And then if I draw my picture here, it's going to do this. All right, now I was missing one thing, and I forgot to bring it up in the last video as well, but try to keep this in mind if you can. We also have this thing called the lattice rectum. And what that is, it's a line that's created from the focus to the graph. So it's this line right here. So if I wanted to find that line, I would have to find these 2 points. And to find those 2 points, that means I would have to plug in for x, -3/2. And I just worked it all out to the bottom right, or on the bottom right there. So you see that when I plug in -3/2, for y I get a +3 and -3. Now these points are pretty close. My drawing's not the best here. But if I were to make it the best, I would have to extend this a little more. So that would be my actual point there. And this one would have to be up there. So again, my drawing is terrible. So that means if I was going to redraw it. So yes, I had to go in and fix it. So there it is. That's a better looking graph than my previous one. So you realize the blue line there is that lattice rectum. I'm just going to spell it for you. So I'm glad I remembered that. So I don't want you to forget about putting that in as well. So this is actually a complete graph. I thought the last one was. I just simply forgot about the lattice rectum. So just keep that in mind as you watch the rest of these videos. When I'm dealing with any parabola, I need the vertex. I need a couple points on my graph. I need the lattice rectum. I need the directrix. So those are all necessary components when I'm actually graphing one of these parabolas for full credit. There you go. And before I forget, I almost forgot one thing. Don't forget about the focus as well. All right, that's it.